This video is about a simple but important problem. AI agents often lose track about what a person is talking about when they ask a follow-up question. So if someone says, "Use the second option presented to me," that only makes sense if the agent still had the earlier conversation where the options were presented in the first place. Without that context, the agent has to ask, well, which option? With the concept of conversational memory, the agent can then connect the follow-up question back to the current thread and continue the work that it was doing. So before we really get into it, here's the basic problem. People, when interacting with agents, do not usually repeat the full context of a task every time they say something. If you and I were working through, say, a logistics issue together, I might say, use the second idea presented or make this customer facing, and you would know what I meant because you remember the conversation we just had. Whereas an AI agent doesn't get that context automatically. If the second message, for example, arrives as a brand new prompt, the agent has to ask, well, what does the second option selected refer to? Or it has to stop and ask for clarifications. So in this walkthrough, we are going to do three things. First, we're going to see how follow-up prompts fail when an agent has no earlier context. That should be pretty obvious in and of itself. And then we'll run this again with the active conversation attached. And then we'll finally look at the trace that results and the code that makes the conversational history that we expect today inspectable. So let's start with the idea of the follow-up itself. An operator says, use the second option and make the update customer facing, whatever that might mean. Now, in conversation, that sounds really simple because as people, we assume that the other person remembers what we were just talking about. But if the sentence shows up as a new request, the agent doesn't know what the second option means in any type of agentic interaction. So in a logistics problem, it might mean, well, was there a route list? Was there a shipment? Which customer was this for? Which ETAs should go in the update? In a memory-backed run, the agent is still in the same conversation. It has access to the earlier route options. So it can understand that the second option meets route 2. So here's the behavior difference. Without any type of conversational memory, an AI agent asks for the previous route options. This isn't necessarily a failure, it's actually the safer response because the agent should not invent details for a customer-facing update. But with conversational memory, the same follow-up becomes actionable. The agent can write the update using the customer's name, the selected route, the ETA, and any types of handoff dependencies from earlier processing. Now the model didn't change, the user message didn't change. What changed is whether the agent received the earlier conversation along with the follow-up. So let's use a framework called Agentspan to see how this is actually coded in practice. We're first showing the no memory execution. The agent sees this follow-up prompt, but it doesn't have the information it needs. It doesn't have the shipment ID, it doesn't have the 2 route options, it doesn't have the ETA, it doesn't have the customer name. So the output says the reference is unresolved and there's time asked for clarification that might be wasted. And now this is what we want from a careful agent. If it just guessed, it could send the wrong update to the customer or choose the wrong recovery path. Now this is the same follow-up, but it's part of the active conversation. The trace shows that the agent can move forward and call the customer update tool. It knows that when prompted with second option, that refers to, in this case, the expedited reefer courier route from the earlier tool result. And now we see the final output includes the shipment, the customer, the ATA, and the operational dependency. In plain terms, the agent can now say, we can still make today's receiving window, but the handoff needs to be confirmed within 45 minutes. So a really useful part of conversational memory is it lets people speak naturally while still giving the agent enough context to act safely. So let's now talk through the conversation that made the follow-up meaningful. First, the operator asked for recovery options for shipment COLD 3187. Then the routing tool that the agent used returned 2 choices. Route 1 would arrive tomorrow, Route 2 would arrive today at 1840. The agent replied with a recommendation for Route 2 that called out the important dependency. The doc still has to confirm the handoff. Only after all of that does the operator say, okay, use the second option. So the last message is short and on itself, it lacks context, so it depends on the whole sequence before it. So the example is a cold chain dispatch workflow here. Shipment COLD 3187 is delayed at Cedar Junction. The load is still safe because the temperature is stable, but Harbor and Pine Grocers has a receiving window that closes at 2000 hours, so 10 p.m. Route 1 is conservative. It keeps the load safe, but it arrives tomorrow and misses the customer window. And then Route 2 is the better path if the team can move quickly. It uses an expedited courier and gets to the customer today at 1840, so around 840. The catch here is the handoff. The dock needs to confirm within 25 minutes, or rather 45 minutes, otherwise the recovery plan may not work. So this setup execution is where the useful context comes from. The agent calls the shipment recovery tool and receives the two route options. That tool result is not necessarily a long-term customer preference. It's not something the agent needs to remember forever. It is simply contextual as part of the current conversation. The next follow-up then depends on it, so it needs to stay available for the next run of or processing of the agent. So here in Agentspan, here's how we keep the conversation connected. This code change is small, but it does represent an important boundary. This conversation memory object is the message history the model can use for the active thread we're on. In this example, it is bounded with a parameter called max messages set to 20 so that the thread doesn't grow forever unbounded. And then the session ID tells Agentspan that these executions belong to the same dispatch conversation. Together, these two pieces let the agent connect the first request, the tool result, the agent reply, and the later follow-up. So for a production agent, it's really not enough to know that the model produced some kind of answer. Engineers need to see what the model saw. Did the follow-up include the earlier route options, or was the model just guessing? They also need to know which run the follow-up belonged to. Was it a new request or part of the same conversation? And they need to inspect what actually happened. Which tools ran? What did those tools return? Where did the final customer update come from? And this is why conversational memory as an observable object is important. It is a way to keep follow-up work grounded, inspectable, and safer to run in real business workflows. If you want to build this kind of durable agent workflow, take a look at Agentspan on GitHub. You can also learn more about Agentspan with Orcus at orcus.io/Agentspan.